Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface. And we talked about the overloading and overloading of the native methods and how JNI creates the unique signature for the overloaded native methods in C++. And the key takeaway was that it adds a underscore and then the method parameter signature. And we said that it's very important to understand how this works, because if we need to manually write our header files, which I don't recommend it's always better to use a tool like Java H or Java C to generate that. But if you want to write it manually, we have to be aware of these conventions that the JNI follows for overloading of methods, native methods. And we said that a slash in the parameter signature, a slash is replaced by underscore. So if we have an object, for example, maybe in this slide I have so for example, if I have a double array, basically if I have an object like a string, its signature is L Java /lang /string semicolon, and we cannot have a slash, so a slash gets replaced by basically underscore. And then we said that semicolon in the parameter signature is replaced by underscore 2, and then a square bracket in the parameter signature is replaced by underscore 3. So this square bracket appears in arrays. So if I have an array of doubles or an array of objects, we have the signatures square bracket, the type of the array, like double in this case, right? Square bracket D means it's a double array. And then we cannot have D. We cannot have a square bracket in the method in the function name, so we replace it by underscore 3. That's the convention that the JNI follows. And semicolon, so if I have an object, so back to our previous code that we wrote, we saw that for example func, if it's just a double number, it's underscore D. If it's double array, it's underscore, which indicates an overload, and then a square bracket D, but then a square bracket is replaced by underscore 3. If we have an object, then for example a string, then its signature of a string object is L Java /lang /string semicolon. So L and semicolon are part of the signature of the object. And then we said that we cannot have a slash in the function name in C++, so a slash is replaced by underscore. L is fine, and then semicolon, we cannot have semicolon in the function name in C++, so semicolon is replaced by underscore 2. So basically a slash becomes underscore, semicolon is underscore 2, and a square bracket is underscore 1. So then the question is this. So here's the question. If we have underscore 2 and underscore 3, then obviously we should have something for underscore 1, right? So what is underscore 1? So underscore 1 is basically should replace something in the Java declaration. So what is it, right? So actually underscore 1 is something that we typically don't see. That's because of one of the Java convention. So basically we know that underscore 1 basically in the JNI, the way that JNI creates some overloaded functions, or in general any function, any method name, underscore 1 is basically replacing underscore in method name. So that's why I said this is one of the Java conventions, because we typically, as a Java convention, is that we do not use underscore in method names in Java. I mean, it allows you to do that, but we typically don't do that. We use a camel case, which is a camel case naming convention. All right, and camel case is something like this. So instead of saying my underscore func, which is basically a typical convention in C++, everything is lowercase letters, but then the names or the meaningful parts of the names are separated by underscore. In Java, basically we use this convention of camel case. So my and then func, and func, the first letter is uppercase except for the first word, right? So instead of having my underscore func, we use my capital case func with F is capitalized. So because we use this JNI, we don't typically see this _1 in JNI headers. But if we actually use an underscore in the name of the method that we write, we see that these two words are now separated by my func. So if my func is basically the name of my method, the method that I have, then this gets replaced by my _1 func. And _1 means an underscore in the actual Java name. All right. So in order to show this, I'm going to create another class. Let's call this overload, just the overload. All right. And then I'm going to create a method, public native double my func, my _func double x. All right. And then I'm going to create another one, for example, my func text or a string text. So what happens here, I'm doing overloading of native methods. So JNI has to add those __. And then, so the method signature is basically a double. Here, the method signature is __ a string L Java /lang/string semicolon, and we know that the slash becomes underscore, and then a semicolon becomes _2. All right. But then there's another thing. We said that the signature of the method is Java _ package name test2 _ class name overload _ method name my _func. So I'm going to use let's say parentheses here to just emphasize that what happens. So maybe also I'm going to bring this down for you to see. All right. But we cannot have underscore because underscore signifies other things in the C++ function that the JNI creates. So instead of having underscore, this underscore in the method name gets replaced by _1. So whenever we see _1, it means it's in the Java method, we actually have an underscore, right? So we expect to see something like this, _1. So Java _ package name _ class name _ method name, that's the default. And then _ signifies overloading, and then the method parameter signature. All right. But then _2 means it's a semicolon. _1 means basically this is replacing a underscore, right? And we don't need to have this underscore in the method name. Let's say in the class name, which is a worst thing to do in Java, but we can. So let's create a class, my _class. So I'm adding an underscore. You should never add underscore to a class name. That's one of the things against the convention. Java allows you to do that, but it's against the convention. Unless it's a very rare case and you have to 100% have to do this, definitely don't add underscore. All right. So let's go back to our overload here. I'm going to create another method, public native double, or maybe first let's just create the header file and confirm that we see this _1. So I'm going to run my Java Edge tool, and it creates the header file, puts it in the header folder of my C++. So here is test2 _ overload, and again the convention is package name _ class name. So this is overload, so we immediately see this __. So that tells me this function and this function in C++ correspond to an overloaded method in Java. And then __d means the method signature, parameter signature is D. Here we have L, Java _language, lang _string _2, which means semicolon. But then I also noticed this _1 in the my func, right? And this _1 signifies that in the Java name, we actually have basically my _func. So _1 means an actual underscore in the Java name. All right. So this was in Java, this was actually my _func. All right. But again, if we don't need to have this, so I'm going to create public native double func. double x, and then public native double func my underscore class, the class that I just generated, obj. All right, so this is a valid overload, but now the parameter signature has an underscore. So let's see what is our expectation. We expect to see java underscore package name test2 underscore class name overload underscore method name func. This is usual, and because this method is overloaded, we have this underscore underscore to signify overload, and then the method parameter signature is d, a double, right? So what about this one? Let's copy and paste the second one. Here we have my class. So let's go to our bytecode view in Java and click on this function. So the signature of this is this one, L package slash class name semicolon. So L and semicolon always signify this is an object. So we end up with this, all right? And we already said that a slash gets replaced by underscore, semicolon gets replaced by underscore 2, but then this underscore that is originally in the name of the type gets replaced by underscore 1. So we expect to see something like this. So I'm going to comment these out. We're just going to basically examine these two. And again, our Java H tool, generate the header file, go there and look at what happens. So this is our header, this is our typical signature, java underscore package name underscore class name underscore func, and underscore underscore again, it signifies overloading, and then d. What about the second one? So I'm just going to copy and paste this here to do a direct comparison. And as you can see, it's perfectly identical to what we expect it to be. Okay, and again, knowing these rules helps you to write the signature of the method without a tool like Java H. But these rules are typically complicated, so it's best to just use an automated tool like Java H or Java C-H. But again, Java underscore test package name underscore class name underscore func is the same. And then underscore underscore signifies overloading, and then this is an object, so its signature starts with L and ends with semicolon, and then semicolon is replaced by underscore 2. But then there is an underscore in the type name itself, right? And this underscore gets replaced by underscore 1. That's why we see on this underscore 1. So when if you don't know these rules and then look at someone else's code and you see all these numbers, this is very cryptic, right? This looks very cryptic to you. But my goal here for you to really understand what's going on. Underscore underscore immediately tells you this is an overload, right? And then L tells you that, okay, one of the parameter types is an object. It starts with L, ends with semicolon, which is underscore 2. Underscore 1 means this in the actual Java type name, the name of the class file or type, whatever type it is, there is an underscore. And again, this is against the convention that we use in Java, so please don't use underscores in your class names or method names unless you really have to do it. Don't add underscores. But underscore is a typical convention in C++ or Python, but not in Java, right? Just stick with the camel case convention. And then so we see underscore 1 and then underscore 2 and underscore 3. So I guess we have a good understanding at the moment about how these underscore 1 and underscore 2 and underscore 3, what is the meaning of these when we see this in a header file. All right, so going back to our PowerPoint, there is one other thing here about the static methods. So far we've looked at the instance methods, but we can also have static methods as well. So let's create a new class. Let's call it overload2. And I'm going to have a method public native double func it double x. And then I'm going to write public static native double func double x. And obviously the compiler doesn't allow us to do this because this is not a valid overload. So compiler tells us there's a duplicate method. So let's have this as, for example, array. So the key here is I want to show you that one of them is static, the other one is not static. And we can put the static keyword or modifier after the native or before it. I typically like to use it before native, so I always say static native double. And if I generate the header file for this, and we know that this is a overload, right? Because if we have this, we end up with a duplicate method, right? Even though this is static, it doesn't matter. Again, when it comes to overloading, the compiler only cares about the method name and the parameter signature. Access modifiers, static, native, these are irrelevant. Even the return type is irrelevant, right? The only thing that matters is the method name and the parameter signature. Therefore, this is an overload. So what do we expect to see here? It's a Java underscore package name underscore class name overload 2 underscore method name func, and then underscore underscore to signify that this is an overload. And then this takes the method of the parameter is d. Here we have a square bracket d, right? This is an array of double, and a square bracket gets replaced by underscore 3. So these are this is the signature, right? And the signature must be different in C++, and it is. So we have this overload 2, and as we expect, we see this underscore underscore d underscore 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 3d. But what is the difference here? We are still doing overload, but one of them is a static. So where does this static come into the picture? The static comes into the picture in the types of the parameters that are passed to this C++ function. So we always have that JNI env. We always have this JNI environment pointer, JNI env pointer, right? But then this method func is an instance method. So I'm going to write it. So this is an instance method. So in order to access it, and in the future lectures I'll show you how to access this, how to call these functions or methods in C++. We need to have a reference to this object, the instance object that we create using the new keyword in Java. So we have to pass an j object, right? But here this is a static method, and static methods are not associated with the state of the object. They are associated with the class. So the first parameter is again a JNI environment pointer, but instead of having a reference to the j object, which means the current object that was instantiated, we have to pass in a reference to the class, and that is accomplished by a j class type. All right. So for an instance method, we pass in j object. For a static method, we pass in a j class. But again, it doesn't matter in terms of the signature of the function. It's still an overload, so we have to still use this underscore underscore and then d underscore 3d, etc. All right. And obviously we have another parameter which is double, which translates into j double in both cases, and an array of double translates into j double array. And again, we will look at these types in more details in the future lectures. All right. So I just wanted for you to see that we can even do overloading with a static method. So I'm overloading a non-static method with a static method, and both of them are native. So we have to again go through the underscore underscore thing for the signature of the functions in C++ that have overloading. But then the main difference is that for a instance method, we pass in a reference of j object, a type of j object. For the static method, we pass in a reference type of j class, a type of j class, which is associated with the type of the class, not the instance method, instance object that we create, or the object that we instantiate. All right. Because j object gives you a handle on the currently instantiated object. And then maybe you want to use some of the instance parameters instance variables of the class in this instance method. You cannot use anything related to the state of the object in a static method. That's why you don't get a handle to J object, you get a reference to J class. Okay, just have this in mind. And when we get to the section that we actually try to calling a Java method in C++, then I'll show you how to use an instance method or a static method. All right, so I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.